no, it's going to open them all. No, 36. Okay, good.
While we're waiting for him to start,
And then
just like to say that I'm Jolly. I'm from the Internet Society New York chapter. We're the fiscal sponsor of NYC Mesh. And I just wanted to mention that as far as the Internet Society goes, that it is our 25th anniversary since it was founded in 1982.
sorry to do it last minute.
It was founded to give an organizational home to the Internet Engineering Task Force, and by Vince Cerf and Robert Kahn, who invented TCP/IP, and so, you know, and what's led to our survival is by the good graces of Vint, who had prevailed on the government in around 2004 when they took away .org from VeriSign. You have .com and .net. That we now own .org, so the money from .org comes to the Internet Society, and some of that money goes to NYC Mesh and pays for your supernote. To celebrate our 25th anniversary, we are having an event on September 19th. It's going to be combined in Los Angeles. They'll be having an induction ceremony to the Internet Hall of Fame, and then there'll be a sort of round robin round the world of all the regions and chapters, and we'll be doing an event where we'll be having a lunch where we go live from the Cornell Club, and they're giving us a nice grant to do this. So we'll be providing a free lunch for anybody who wants to come along, and I shall post this via NYC Mesh. If you want to come along and celebrate the Internet Society, we'll be there. I'll also say that as far as, you know, every year we have a kind of emphasis, the increasing emphasis in the Internet Society is on community networking. That, you know, we believe that, you know, most of the sort of major incumbent reaching out infrastructure has basically been built around the world, and that now, you know, how the next billion get connected is by building their own, you know, their first, it's not the last mile, it's the first mile, and building that first mile out to the nearest node. Our president, CEO Kathy Brown, got up at the Mobile World Congress in Shanghai, made a speech about a month ago, a very good speech, where this is where all the cell providers around the world, and especially in Asia, were, and said, you know, look, you know, if you can provide a pipe for these people that are in all these small towns that you're not connecting to, that they can reach to you, it'll have a network effect that benefits everybody, you know. And it is a thing where, you know, our campaign now is to really get the pipes that exist open to people like NYC Mesh. And it's, you know, it's still, you know, we see right now everybody's talking about net neutrality, but to me, the thing where I see that, you know, a campaign that is working to is like open the pipes. The pipes, we know that the fiber is there, we know that the connectivity is there, it's getting access to that connectivity, and it's something that we're working on, we need to work on our priority for next year.
So, welcome everyone. We've got 5 speakers here today on all different topics related to community networks. And the first speaker we have is Daniela Perdomo, who's the CEO and co-founder of goTenna. goTenna it's an organization I've been interested in for a while, and I finally met up with Daniela last week, and I'm very happy that she's speaking here tonight. They make a small hardware thing, which she will show you in a minute, which creates a mobile mesh network that can run parallel to or augment existing communication networks. And the goal of it is increasing scale, resiliency, and access to connectivity by decentralizing it. She's here to show a presentation on creating and scaling mobile mesh networks. So Daniela Perdomo.
Do you have a card?
So
Do I just speak?
what you do is you wear a mic, maybe. That's
Okay.
Okay, and then you'll just have to click yourself.
Sorry. Oh, on the computer.
Yeah.
Sitting down.
You
I'm
can
gonna
sit
stand
down
up.
or
I'm
whatever
gonna
you want to
stand
do.
All right. Cool. All right. Hi.
All right.
Hi, guys. All right. So, mesh networks are trendy now because I think generally people are talking about decentralized internet more and more and what that means. But what I think is kind of funny about the discussion about a decentralized internet is that we're generally still assuming two things that I think we shouldn't, which is one is we're assuming connectivity, and there's still a lot of places and or people who are disconnected. And moreover, we're talking about building a decentralized internet on generally centralized infrastructure, right? So, and I think part of the reason that is the case is because generally centralized connectivity can do pretty amazing things for us every day. So you want to text or have a video conversation with someone halfway across the world, that heavy infrastructure lets you do that, right? In under a second you can get through transoceanic cables, mobile sites, all sorts of things, all the way back to someone else's phone across the world. And I think that's part of why we don't think about decentralized connectivity that much. And when you put that same infrastructure on top of a more local situation, so let's say you're in here and you're trying to text somebody who's outside waiting to come in, it doesn't make that much sense that you're still going through all these pipes, so to speak, right? And so, I think, of course, we also know that, particularly in urban situations, communications infrastructure is as burdened as anything else. So, the more people are on the network, the worse the network is for everyone, right? And so how is that going to scale as our, planet becomes more and more urbanized? And of course, in extraordinary situations, probably a lot of you, if you were living in New York 5 years ago, experienced this. The biggest problem with centralized connectivity, it becomes more clear, which is that central point of failure problem. So all of a sudden, you have a situation, of course it doesn't happen every day yet, but during Hurricane Sandy, 25% of people lost connectivity in the 10-state area affected by the storm, and in some cases lost it for days, in other cases for weeks. Right? So why is it that we have a communications infrastructure that tends to fail us when we need it most, right? And for me, 5 years ago, that also begged the question, why can't I create my own connectivity? Why can I only plug into it? And this is a good moment to call out the fact that our phones are actually designed not to enable phone-to-phone communication at any practical distance, right? And I think everyone here would agree that the 20 or 30 or even 50 feet, if you're lucky that you get on Bluetooth, does not do that for you, right? And part of the reason for that, without getting too into the political economy of things, is that the people who make the phones are in business with the people who provide the service. And there are 3 real mobile carriers in the U.S. and any other region or country. It's pretty much just as limited, if not more limited. And so, but if we could permit ourselves to imagine that we can create a scalable, decentralized connectivity layer, what might that be really good at? And as it turns out, it would be precisely good at what centralized connectivity is not. So it would be able to increase access, increase resiliency, and also because there's no top-down control, it would also ensure neutrality, right? So if we go back to this, local situation that I showed earlier, right? It doesn't make that much sense if all you're trying to do is text someone outside or even a few blocks away to go through all these pipes. If you could establish that direct, efficient link, that shortest distance between 2 points, that straight line, that would be pretty great, right? And if every phone is a connection point, then you could also imagine that you could leverage all the connection points around you, all the phones in this room, in this building, in the streets outside, and beyond. And so, if we could create a phone-to-phone mesh network, that would be a pretty valuable tool, I think, for local communications that could service entire communities and cities. So, of course, everyone here, you're here at a meetup around mesh networks. You know this is a mesh network, but I want to very specifically talk about MANETs. So MANETs are mobile ad hoc networks. So a mesh network can be mobile, but not the other way around. So a MANET is essentially something that enables mobility. And so in a MANET, by definition, the network topology is always changing. A node is never in the same place. In fact, by definition, it's not in the same place again. And so it's just a much harder network architecture to work with. And that's what we're building at goTenna. So MANETs have been around for a while, but for the most part, they're relegated to really expensive systems that, if I had enough money, I could show you a really big system that is hard to use, guzzles a ton of power, and is really only accessible to special operations forces. And that's also how hard they are to use. You basically have to be trained at Quantico to know how to use them. And they cost, seriously, fully loaded, anywhere from $20,000 to $300,000, right? So it's really not accessible to everyone. It's not really like a democratic technology so far. And so when we at goTenna decided, after our experience during Hurricane Sandy, we want to build something that allows people to create a manet in a way that is easy to use and actually accessible, we had to decide on some core design principles, really because the laws of physics otherwise we'd also end up with a $300,000 device. And so we decided to focus on something that was really small, low power, low cost, long lasting in terms of battery life, and that could transceive over pretty great distances. So not feet, but ideally blocks, if not miles, in other situations, even before it ever relayed. And so as a company, what we're doing is we're building really advanced manet protocols specifically focused on short burst data that can transmit over pretty great distances. That's what we're doing. That's sort of where the core design principles landed us. And about a month ago, we started shipping our newest device, which is this little thing here called goTenna Mesh, that costs under $100. It just pairs to your phone, and it creates the first manet consumer-ready network. And so this is an entirely mobile mesh network. In under a minute, you pair it to your phone, and you can communicate peer-to-peer and peer-to-peer-to-peer. So you can privately and automatically route messages through anyone else who also has one. And what's also pretty cool is it doesn't have to be paired to a phone. You can also drop them in a breadcrumb fashion and create stationary relay nodes. And that's pretty cool as well. But so what I think is really interesting about unlocking this, your phone, in a sense, right? We talked about how phones by definition are not designed to enable peer-to-peer communication. What this does is really leverage the infrastructure that's already there and unlocks it. And as more and more people, there's 3.5 billion people with smartphones today, as more and more people have phones, you can leverage the growth and turn it into an asset as opposed to a liability in terms of like network scaling. And also what's pretty cool about creating an entirely parallel form of communication is that, yes, it's available when nothing else is, but it can also extend, whether you want to call it the first mile or the last mile, it can also augment existing communication networks and just extend the practical edge of connectivity. So, what we might imagine is I think what a lot of us probably here hope for, which is that you can connect, you can actually really create a decentralized internet by connecting mesh to mesh, right? And so the kind of mesh network that we're building at goTenna is very specific, of course, but it can augment other systems and backhaul into different things as well. So you can also free up the centralized pipes to do what they do well. So if you want to FaceTime someone halfway across the world, use the pipes. You want to text somebody across Manhattan, maybe just go through 3 other people on the way there, right? And I think that's pretty powerful. And we can really start to conceive of a future where you might really be able to create the connectivity that you need at any time that you need it. But we've been working on this for 5 years. We released our first product that did not mesh while we got the meshing product ready. So we had a manet product, but it was not a manet mesh. Now we have a manet mesh product. But what we are learning is that there's a lot of questions and a lot of research problems that affect any mesh network, whether it's ours or anyone that you guys might be working on. And so, how do you scale a mesh network? So just a little context on like where we are today. So we just launched goTenna Mesh a month ago, right? Thousands of people already bought it or pre-ordered it, and some are still receiving them. But this is what our mesh network map, this is a self-reported map, showed this morning. So this is how many people and how many different nodes in the United States specifically are being used. And if you zoom into New York City, the New York City area generally, this is how many there are. That's pretty cool. And if you filter out the people who have set up stationary relay nodes, there's a lot fewer, right? But that's how it looks. That's how it looks today. And so, so how do you scale it? This is what we're doing, and I'll specifically talk about New York because this is NYC Mesh. For one thing, for instance, in addition to all the people who are buying devices, we've actually earned a grant from the city and the federal government. It's a resiliency grant, and we're going to be distributing over 20,000 goTenna mesh units to people in the low-lying areas of the city in the FEMA-designated 100-year floodplain. That's pretty cool. So we're going to be able to give out 20,000 devices that people can use both on their own person as well as to set up relay nodes. So, the map that I just showed before of New York City will be, denser with 20,000 more soon. Of course, we hope that we can integrate with other existing community Wi-Fi networks. So, through backhaul, we can interconnect into, the global networks, right? So we have those plans, but, I think that what we've started to learn is that when you ask, how do you scale a mesh network, you're really asking a lot of other questions. And so, this is a list of just some of the questions that anyone who is working on any kind of mesh communication network, whether it's stationary, as most are, or mobile, is you have everything from zero start problems. So how do you, incent participation before it's, useful at scale? Coverage, for as magical as meshing is, it's not that magical if there's not the nodes in between to get you to where you're trying to get to, right? Also, how do you make sure that you have the capacity you need, where you need it, when you need it, to handle all sorts of different kinds of traffic, volumes of traffic? And of course, we also have to deal with power. Unlike other communications networks, mesh networks require not just your own power, but those of others, right? So how do you incent the sharing of energy resources? And spectrum. Spectrum is finite, so whether you're working on like 2.4 gigahertz or 5.1 gigahertz, or in our case, we're working on 900 megahertz, the public spectrum on that end. That is also a finite spectrum, a finite resource that is moreover regulated by the government. So, how do you incent fair use of a shared limited resource, right? And because by definition, mesh networks are local networks, they're community networks, how do you incent the bridging of the global communications gap? How do you incent people to put up those bridges, that backhaul, that gateway into everything else, right? And so the question, I think, of how to scale mesh networks actually becomes, how do you incent participation and fair use in that decentralized network, whether it's mobile or off-grid or it's on-grid and static? All these questions you have to think about when you're building your protocol and giving it the functionality that you do. So for instance, we have artificially constrained our product today to focus on short bursts, in part because I don't have $50 billion to go buy white space, right? And if we let everyone transmit all the time, then it would very quickly become just a crappy walkie-talkie system, right? So how can we build incentives and behavior into the protocol itself so that we don't actually have to artificially constrain it, right? And but because people are selfish and not like always logical also, you have to think about this pretty hard. And so what we're doing, and what I'd like to invite anyone or everyone in this room to collaborate with us on, is we are starting to work on a non-proprietary protocol layer that will help address a lot of these scarcities and coordination issues in any mesh network. And the point is to create a protocol layer that can help any and all mesh networks, not just ours, scale and address this so that it's built into the way the networks are used themselves. And so, I invite you guys to sign up to learn about our Mesh SDK, which will be available later this month. So very easily integrate into anything that you're building. Email me directly. We also have a public message board where we're discussing things like this. And yeah, I think that's pretty much it. I think there's time for Q&A, right, Brian? Yeah. I don't know where you are.
We have a mic for questions.
Oh, okay. This is going to be on YouTube.
Who wants it?
Yeah.
Just a minute.
Hi, thanks for the presentation. I was just wondering how much the device is currently being sold for.
Sorry, what was the question? I can't hear you.
I was just wondering
YouTube can hear you.
now I'm going to yell into YouTube. How much is the device currently being sold for?
It's 2 for $179, and it gets progressively cheaper the more devices you buy. So it's basically 1 for $85 at the most expensive. And what we're finding is that over 50% of people who bought goTenna Mesh have bought 4 or more. So they're buying it with this idea of at least creating a little network with their neighbors, their family, their friends, right? But what's pretty exciting is if you look at, I'll go back to just like how this looks already. These people didn't buy it together, right? But in a way, we created this map called imeshu.com so that people could actually visualize with something that's otherwise invisible, right? And my hope is that we can, in the not too distant future, be selling them one at a time. But we don't want anyone to have like the crappy experience of being like, I bought one and there's no one near me. But I think with time, it's going to happen, I think, a lot sooner than we expected, because people are buying many of them, and particularly in urban areas. You can see here in the map of the United States. If you zoom in further, it's Miami, it's the major cities in Texas, it's all the big cities on the East Coast. Toronto, Portland, Seattle, San Francisco are slammed, right? Yeah. And then it's free to use after you buy the
Hi. Thank you. The original unit operated on the MURS frequencies, correct?
Correct.
Okay.
Yeah.
And now the second generation is on 900?
Correct. Yeah, the
Okay.
second generation product works on the ISM civilian band, and it'll tune to different frequencies and emitted power based on the region that you're in. So here we conform to what the FCC makes available in the CE region and slightly.
Okay. And might your organization have plans of developing a product that could plug and play into, for example, a Battlemesh? You know what that is? A Battlemesh? Okay,
Yeah.
something like that. Therefore, users could use whether licensed or not unlicensed frequencies, similar to MERS, or if they have their own frequency allocations, or if they're amateur radio
We
operators.
have
Et
a
cetera.
goTenna Pro line coming out at the end of the year that's intended for licensed spectrum users, so that works throughout UHF and VHF. Is intended specifically for public safety, industrial, and other government uses, and that has variable power up to 5 watts, obviously variable power throughout the spectrum, but you have to at least sign off the liability that you have access to the licensed
I
spectrum.
think
So that already exists, and then in addition, we're coming out with a hardware SDK version of that product. So if you want to put it into a drone or anything else, you can do that as well.
So that last item you mentioned
Yeah.
does not have a transceiver.
The SDK? No, it has a whole
Okay, because what I'm driving at is something where I have the transceivers. I need your controller of sorts for an
Basically
existing
the
radio.
network, smarts,
Don't know what that is.
just the firmware, the network protocols is sort of what you're looking at. I mean, eventually
I
we'll
want a box that I
probably-
can plug into the speaker microphone connector. Now I have a mesh network device.
I mean, our protocol is specific, it's very, it won't work on other hardware. Not yet. Not until we make a version of the network protocol as we learn more that can work on other hardware. But so not yet. But that doesn't mean that. Yeah, it doesn't mean that we wouldn't like to. So we've started. Our first product already had an open SDK on the software side. Mesh will be released in a few weeks. We have a hardware SDK coming out later. I mean, we want to create a system that's as open and useful to people as possible.
With that
So,
hardware SDK, what kind of a price are we looking at per unit?
we are literally in
Guesstimate?
the process of making it, but the idea is to make it accessible for people to be able to develop.
Not just people with federal grants,
Correct.
public safety,
Yes,
et cetera.
yeah, we would make that available to the developer community at large.
Very nice, thank you.
Yeah.
Okay.
Is it mainly for voice, or is it anything other than voice?
Do you want to go next?
That's a good question. So it's actually, as I mentioned before, we are focused on short burst data. Doesn't mean that we couldn't do persistent voice or any other high bandwidth communication. But because we're working on limited license spectrum, we are making the most efficient use of it possible. And so we've decided to focus on short burst data. And so what you get for giving up high bandwidth is you get really great propagation. So in a city like New York, sometimes you can get a quarter of a mile or half a mile just point to point before you can mesh, right? In the outdoors, you can be getting 4 miles, 10 miles, and put it on a drone before you can mesh again. And so what we're giving up is voice, but what we're getting back is better coverage with less nodes. Yeah. So again, that's part of why we're interested in building probably a blockchain-like protocol layer that lives higher above the communication transport layer that will allow us to open up the protocol more. But if we open it up today, anyone who would use it, the second someone decides I want to try to stream Netflix, over many packets, would ruin it for everyone else.
Right.
So that's that whole idea of how do we communally consent, participation, but also the fair use of a shared resource. So, you know, the bottom-up stuff has its own like complications.
Can I ask, what about the CBRS 3.5? Are you planning to use that?
What is it, sorry?
Citizens Broadband Radio Service 3.5?
Oh, the ham? Is that the ham?
No, it's a new thing. The FCC set it up.
So our product, the core RF hardware that we create is technically modular, but we would have to like create a new version for each frequency, and we get emails every day.
Can I suggest you look at this, because they just produced a whole new bunch of unlicensed spectrum.
Yeah, I mean, I'm sure our team knows more about all
Okay.
We have a map of, or like a spectrum
Okay.
map outside my office, actually. Yeah, I mean, the point is we'll make it wherever there is need, but there would have to be demonstrated need for us to do. But that's also hopefully why, as we open more things through software and hardware, people can build their own things. We don't want to build everything. We're really we're a protocol company. We're just making hardware because it's not your phone today.
Okay.
Cool. All right.
Thank you.
So next speaker is Ingrid Burrington. She's an artist, writer, educator, and she says she's based off a small island off the coast of America.
Just trying to not be part of America if I can.
You've probably read her articles. She's very prolific and journalist. And this presentation is about a project of hers, networks.land. And you've developed this with Surya Matu.
Surya Matu, yeah.
I'll just get this loaded.
Yeah, thanks. Cool. All right. Thank you, Ryan, for inviting me to come talk with you, and thank you all for coming. Hi, so my name's Ingrid. I am an artist and educator and freelance writer, and I'm going to talk to you. Am I talking loud enough? I realize I can. All right, I'll work on that. So I'm going to be talking to you very briefly about networks.land, which is a project that I've been working on with my collaborator Surya Matu, who couldn't make it this evening. That is basically a curriculum development project that we started in late 2015 with the support of a Knight Prototype Fund grant, and it emerged out of our shared our kind of the weird places where our backgrounds kind of overlap. So my background's in art, Surya's was in electrical engineering, and we both kind of had come to the conclusion that no one actually understands how the internet works, and that in general there are these gaps that currently exist in the admittedly thriving space of like code literacy and digital literacy education, especially for young adults. There is still this huge these many missing parts, and it leads to, from a 9-year-old to software engineers not being able to give you any coherent articulation of the network. And to be fair, that's also because it's very complicated and abstract. But I don't know, a lot of my work has to do with network infrastructure as geography and political landscape as much as it is important technical landscape. And I think that I've found in my experience making the stuff of the internet really concrete is a really useful way for making conversations about technology, not just conversations about, employability and or abstraction. Because I've noticed with a lot of the Learn to Code initiatives for young adults, it's sort of framed as now you can get a job at Google, or if it's more in a media literacy environment, it's sort of now you can be a forthright consumer of information online, which are both totally important and valid things, but I think there's something else that's worth probing into. So we started working on creating these sort of modules of different activities that could maybe introduce some of the more material and frankly some of the more human bits, because even when you start talking about teaching core protocol stuff to kids and young adults, you're talking about teaching children that ultimately the internet is a bunch of decisions that some men made in the 70s that we just all decided to go with, right? I'm gonna try and run through some of the activities. This one's a self-evident one, everyone's probably done this if they've done any teaching, which is get kids to tell you how they think the internet works and make a picture of it, and it's usually pretty illuminating. In our experience, they almost always This was ranged from like working with like 7-year-olds to like 14 to 15. Like generally there's kind of a complete ignoring of the idea of wires. Everything moves through the air, which makes sense, right? If you've grown up mostly using Wi-Fi. We would do like these sort of, in my own like work, I do a lot of like walking tours and field trips with kids. We went out to Point Arena, California, which is a small town kind of up the coast, 3 hours north of San Francisco, that's home to a submarine cable landing. Has anyone been there? It's one of my favorite places. I highly recommend it. The first slide actually was from this presentation was of the original coax cable that's sticking out of a seawall on the beach out there. This is actually, sorry, I should have shown this picture sooner. That's Surya, and those are some 7-year-olds who are way more excited about a fiber optic cable than I thought that they could be. And the thing this photo is actually for is for the thing on the table, which is this like topology modeling exercise that we designed in collaboration with Sam Kronick and Tara Shee, who are 2 designers based out of Oakland, California. And it's, the idea is that there's sort of like a visual vernacular for what often you might see as kind of those like shitty Cisco icon diagrams with like lines in like invisible space. So trying to make that a little more tangible and playful. So, you have wireless connectivity that's like, little hoops and dowels, and you have wired things that are kind of running into like this little data center card, and they're sort of modular, and we, there's a difference between cellular versus Wi-Fi, and so we had to color code it. It's a whole thing. And a lot of it was just trying to make these sort of objects more like make those something that like a, student would actually go like see, when they saw it in the world, they'd be like, oh, I know what that is and I know what it does, right? And, because not everyone has a really great design studio at their disposal that has a wood shop and will, hand flock tiny modular wooden blocks for you. We've been working on kind of different variations of kind of achieving the same thing. I just wrapped up revisions on a curriculum development module for the city's Computer Science for All initiative. So trying to come up with the way that you do this activity with like $20 at Michael's was kind of a fun challenge. And my favorite part of this activity is actually the part where after you've gotten the different groups, like you put them in like teams and have them make a little network model, is then say like, okay, now all of your networks have to talk to each other, and then you show them 60 Hudson, and it gets, it's kind of nice. This is probably too complicated to explain, but this is a relay race activity to explain how packet switching works with different things you might go look at on the internet, broken up into literally puzzle pieces. Gets a little complicated. They have to run across the room, but it actually it's kind of fun. This is a tabletop role-playing game about top-level domain acquisition. Anyway, ultimately the thing that's kind of more like important than like cool pictures and like fun things is like we've tested out and workshopped with kids is like the actual documentation stuff. So the project is called networks.land because that was the domain that was available. So we put a lot of this material online as sort of like short summaries. And I don't know, for me this has been like, as someone who's kind of a feral educator, the process of learning how other people structure their curriculum was really useful. This is a screenshot from like the city's like CS for all kind of like formatting of thinking about like what are your expectations of like what do you want the kids to get out of it, and like how do you decide that they've like achieved that goal. I guess some like things that I guess I'm still actively thinking about with this project. Professional development versus boutique consulting. Like I can get kids excited about this stuff as much as I want. Surya and I both like really enjoy kind of jamming out on creating the like actual activities and working on them with people, but like someday we will die, right? And we can't be everywhere. And so making this a lot of this is more explicitly curriculum development than like I'm gonna like spend the next like 25 years in a classroom, because ultimately there's like lots of other classrooms that it would be kind of better to get this spread out to. Another thing that we've spent some time trying to kind of figure out where to position ourselves in is like the sort of questions of like how heavy-handedly do we talk about the politics of these like systems, and I think some of that has to do with the age range, but basically we figured out pretty quick that if we don't talk about the fact that, you know, these technologies are political, someone else will put their politics in there for us. So it's something that, like, at least in the written material, we've tried to be a little more self-aware about. And then I guess the last thing that has been interesting in trying to figure out where we're moving with this material is we don't really know what subject matter this is taught in. You know, like if you're looking at this in a K through 12 setting, we were kind of looking at like a junior high environment. The stuff we just worked on for the DOE was for 10th graders. And some of this is for, like, some schools have electives for this stuff. A lot of public schools don't. And ultimately where a lot of it ends up being, and where we found kind of the most comfortable place was like social studies, because at the end of workshops, a lot of times we do these sort of like post-mortem like follow-ups, like what are things you wish that you knew more about that we didn't cover, and like a big one was just history, like because they don't know where the internet came from, they don't know why it's fucking called Facebook, which like they're always really disappointed when you tell them what it really means, and I think that trying to there's like I have a friend who does a lot of stuff related to trying to like improve ethics education in computer science, and I think in some ways trying to just make computers inherently more part of an understanding of how we think about like ethics and how we think about like kind of subjects that are more inclined towards ethics, like treating computer history less as kind of this anomaly of the rest of history and actually just like kind of inherently woven into this material, is maybe one approach to doing that I'm kind of excited about. Apparently there's like a whole section of 10th grade social studies in New York City public schools about globalization, so we fit right in, which also, isn't that kind of great? So yeah, those are some of the things that, you know, happy to talk more about those. If any of you teach or know other teachers who are interested in this stuff, please let me know and get in touch. Thanks so much for your time. That's submarine cable again.
Abe, I'm curious how you get kids of that age range to be interested long enough in the topic to learn something. And I think it's a very interesting topic, so I agree with you. But usually it just seems like, just from experience having explained internet, computer, whatever to people for many years now, they will turn on for a while, and then as soon as you get, 2 subjects down in a 10 subject long thing, then they'll just turn off.
I mean, I think some of it has to do with how you break it up. Like in general, like we only will do like kind of one activity for like and also like considering like the how much time you actually have in a lesson, because if someone gives you like a 40-minute classroom like period, you actually have at best 20 minutes, right? Because you have like everyone coming into class, everyone getting settled, you have everyone kind of packing up to leave, like you don't actually have the amount of time you thought you had. So some of it's just kind of budget, like being really clear about like what you can actually fit in a short period of time. Mm-hmm. And I mean, we've also been very privileged to, a lot of our workshopping of this material has meant, because, we're not in the system as it were, has been like self-selecting audiences, right? Like we're going to after school programs. Students are choosing to be part of this like workshopping of like new material. And so we like the real like kind of like rubber hitting the road moment is really in the fall and spring, when like I do professional development with educators and they say like this isn't working or they will lose it. It's like that. That's when the evaluations like really like get more kind of like real.
Okay. Yeah. Interesting.
Is there an ultimate goal that you're working towards? Kids learn how the internet works, great. But is there more like a call to action that you want to drive towards?
I think there's kind of a fun, like full communism, but a fundamental rethinking of the ways in which, and maybe a more holistic approach to education about and living with technology as a whole, right? Because I think the idea that that the systems that are increasingly dictating huge parts of how everyday life functions, at least, you know, in like big cities and other parts of the world, like the fact that that's kind of like divorced from like material things and human beings and lots of other stuff, like I think that there is a entry point to like kind of making that more understood as just like part of the world and part of like a larger systemic thing, and not just this thing that happens somewhere else and is managed by someone or something else. I don't know if that was like a great answer, but I think a lot of it's like just recognizing that there are, that it's like to achieve like any kind of like major changes in like public understandings and conceptions about technology and like network systems and infrastructure, like you have to start like very, very early on. And this is stuff that like frankly like it doesn't get like I know all of this stuff just because I was like curious about it. A lot of my peers who have computer science backgrounds knew less than I did when I started getting into it. So yeah. Now there's a video of me on the internet saying full communism. Check that out for both of this.
Thank you.
Thank you.
The next speaker is Rory Solomon. He's a doctoral student here at NYU, and his research focuses on mesh networks, wireless infrastructure, the history of software and computer programming education. His presentation is on Battlemesh, which is where all the mesh protocols meet and battle it out to see which one's the fastest. It's held like every year. I've been meaning to go. I haven't made it there yet. And he also visited some of the mesh networks in Europe, so he's going to speak about that.
Cool. Thanks. Okay, thanks everybody so much for being here, and thanks Brian for having me. Yeah, I think Battlemesh will be actually probably only about 20 to 30% of what I actually talk about. As Brian mentioned, I spent the summer visiting a few of the other more well-known community wireless / mesh network projects that I was aware of, mostly in Europe. And so I want to talk about share some stories from those and some photos. So yeah, I guess I'll start. This is Battlemesh. It was held this year in Vienna. It's the 10th annual Battlemesh. Has anybody ever gone before or heard of this before? Okay. So it was. I mean, I'm like a sort of borderline technical person, so I was kind of there as an anthropologist, and I participated somewhat in the technical discussions. I think the main thing happening right now with Battlemesh is that, as the name implies, it's this. It's meant to be a kind of battle of the mesh protocols, and that was definitely like the main event of the conference. But it was, or I don't know if you could even, I guess calling it a conference is part of what's up for debate, because the other part of the activities are like talks and presentations about people that develop firmware, people that develop protocols, people that do computer science graduate research about deploying mesh networks in different contexts. And so I tended to be kind of more focused on that, just given my background. But there was some debate at the end about what the future of Battlemesh should be. Some people actually said maybe we should call it Love Mesh, because they don't want to, you know, like this whole the war fighting aspect was maybe not the most important part of it. This was the first day. It was hosted in Vienna at a place called MetaLab. It's kind of a hackerspace in Vienna. They have their own community networking project called Funkfeuer, which means radio network tower. It borrows its name from like fire warning system. Funkfeuer, yeah. Radio network fire. That's their kind of NYC mesh project in Vienna. This is the whole group. This is pretty much everybody who was there. this was the main space where all the talks were given, and then what most of the people here are working on is the test bed. So like there was a lot of much ado about the test bed. So it was setting up all something like 15 Wi-Fi nodes throughout this space that was donated by the Vienna Folk Art Museum or something. So at one point I decided to just go around and take pictures of a bunch of the nodes just kind of for fun. So they were spread out over 4 rooms in this space just to create a kind of artificial mesh, and then there were several tests that were run on this test bed of nodes, mostly ping tests, which were just flooding the network with pings and then testing how many pings reach the destination for each protocol. And then there was also iPerf tests that added a bunch of sort of background noise traffic and then tested the performance of the various protocols through that. So while everybody was kind of like hacking and like running all these tests, I was kind of just like dilettante walking around taking photos of the nodes. But the results of the tests were posted online on their GitHub. So I suggest you take a look at that. It's too much for me to, there's not like a zinger punchline. The result of the test bed Battlemesh was, but just to sort of briefly summarize, BMX and OLSR version 1 did the best for the ping tests because they took more conservative routing paths, so they delivered a greater percentage of their packets. But in the traffic, the heavy traffic situations, BMX 7 had a higher performance in terms of the actual ping times. But there's a much more elaborated presentation of statistics if you go to their GitHub page. I can send you the link after. I didn't put it in here. Yeah, and at one point I just started taking pictures of people's T-shirts because as this kind of an anthropologist, it's hard to get nerds to talk about why they're there and what it means to them. And I realized like the messages are all just on people's T-shirts. So the general interest, I think, of people in Battlemesh was this. There's no cloud, it's just other people's computers, which I'm sure everybody here is familiar with that kind of ethos, and that's why you're interested. And then this is German, wir sind das Netz. It just means we are the network. So the response to this kind of, the first one is kind of this idea that, we can build our own, that's why we're all here. We can build our own mesh network. This was a really nice moment. There was a lot of different, I guess, I don't want to say conflicting because everybody was like very much complementary in their efforts, but there were several different firmware developers and protocol developers here. At this particular moment, the guy in red in the back top, his name's Nicholas Passe. He works with an organization called Alter Mundi, like alternate world. They develop a product called LibreMesh, which is very similar in a way to goTenna, to the presentation that we saw earlier. They're developing a low-cost mesh-enabled router that can be added to an existing mesh network just by turning it on and clicking through some graphical web page config screen. And it kind of auto-configures itself by pulling in config information from neighboring mesh nodes, and they've been rolling that out in the developing world in several different sites, and they're actively developing that. So they have their own GitHub. I would suggest you check that out. But this was such an interesting moment to me because Nico was working with some other people, mainly this guy and these other guys here who have developed other firmwares based off of OpenWRT, and I don't know if you guys know of Lead, and one called Gluon, which is being used in Germany in a lot of the mesh network projects there. And so they sat down together and they were like working out the differences on these different forks that they had each done from OpenWRT in an effort to kind of like hopefully merge back together these different these projects. And so they were like actually working through some of the different features and actually getting into some of the code and stuff. So I thought that was like a really nice moment of how the Battlemesh is maybe, the future of the Battlemesh is maybe not so much about battles and more about joining up some of these different projects. So after that, I visited Giphy. Has anybody ever heard of, have you guys all heard of Giphy? Okay, so Giphy is here in Catalonia. I just included this picture for context. Barcelona, and then these two points here are a small town called Gurb and a slightly bigger town called Vic, V-I-C. And this is where Giphy kind of originated. So I wanted to take some time on my visit to kind of like go back to the, the original site. So I got in touch with Ramon Roca, who was, I guess, kind of the founder of Giphy. He picked me up in Vic and then drove me out to this small town Gurb. So this was us driving, and here he pointed out that this red building, which I'll show more in a second, was the municipality building in Vic. This was the first place where Giphy sort of started. They had a DSL connection here, and they set up a wireless link from here to the top of this building, and then from there they had one antenna pointing this way and another antenna pointing out towards this rural town. And that was the first, so this is the municipal building where they had DSL and an antenna on the roof. This is Ramon pointing me towards the antennas that they have up here. And you can kind of see they have an access point here that provides internet for this area. They have an antenna, point-to-point antenna pointing down to the municipal building, and they have another antenna that you can't see here that's pointing off into the rural village. And from there, they set up a mesh of wireless nodes that connected quite a large bit of farm area within rural Spain. So talking to Ramon was just like so fascinating. He gave me so many stories about the development of this project. I took a picture of this. This is the highway that goes from Barcelona to Vic. And this was important because the performance of their network was originally quite slow. And so they were trying to figure out how they could get a connection to the internet exchange in Barcelona. Should I do that? Okay. They were trying to figure out how they could have a point of presence at the internet exchange in Barcelona, and they wanted fiber to. They were trying to find out if they could get fiber to connect their Wi-Fi mesh in this small town to the internet exchange in Barcelona. This was a pretty new highway. They knew that there was fiber under this road, but everybody that they asked said no. It's not there, or you can't access it. It's private, whatever. It's a lot of it is owned by Telefonica, and Telefonica has taken over a lot of the previously public infrastructure, but with the stipulation that they have to be able to lease it back to other public organizations. But Telefonica was like, no, there's no fiber there. So what they did was he got a bunch of farmers with their tractors and said, all right, we're going to then have to run our own fiber along this highway from Barcelona to our small town. And we'll do it on Saturdays and Sundays from like November to January. Basically, like everybody who's going to Andorra to go skiing for the weekend for an entire season will have to take the frontage road, which will take like 5 times as long. And they're like, oh, actually, I think maybe there is some fiber under that road, but you can't use it. So they went looking for it. This was the first place where they found an entry point to the fiber that was under this highway. And they pried open this manhole and actually just connected it to a post here. And this, you can see this is the first bit of fiber that then runs out to this rural village. And then they initially shared the fiber through the existing wireless mesh that they had, but then realized that fiber was so cheap, they just bought a spool of, this is the spool of fiber that they're now using as a picnic table. They made me the most delicious paella, and we sat around and ate this paella on their spool where they had bought fiber, and then now, so it still, I would say, is a mesh network, but it's actually not a wireless mesh. They've just connected this entire farming area with fiber. And he's like really excited about fiber. His idea was that fiber is so cheap that a lot of people, that like one of the things that they were doing was trying to pay for it by pulling up the copper and selling it. And the resale price of the copper was actually enough to pay for the fiber because it's so much cheaper. But still the logistics of it are still quite complicated. And so, how much time do I have? Okay, I'll try to go. So the most exciting part about Giphy to me was that there had been a lot of other independent wireless mesh projects throughout Catalonia, mainly in there were several in Barcelona. And now Giphy, which started in this small rural village basically has kind of like subsumed all of them, not necessarily like replacing their infrastructure or their protocols or anything like that, but it's kind of like taken over as like the governing body of all these other previously independent projects. And the reason, I think, is because they, a lot of the other projects were contingent on like volunteer labor and things like that, and they were purely like just almost like hobby projects or whatever. But Giphy actually was accommodating of commercial activity within their network. They said you can make money off of Giphy, but Giphy itself, the backbone, if you will, it's not really a backbone, but like the backbone of Giphy will be an open commons infrastructure that nobody owns, but will accommodate commercial activity within it. And so this was so fascinating to me because this spreadsheet, he was taking me through their whole governance policy and how it works. Basically, if you're a commercial, if you're an ISP within Giphy, you can provide internet to people, like to grandmas on the farm that don't know how to set up their own node, they can't set up an antenna, or when lightning strikes, which is very common, they don't know how to repair their antenna. So you could be a commercial ISP, to, you're on call to repair antennas and stuff, and you can get paid and you can charge whatever you want. But the Giphy organization comes together and decides, for the purposes of internal calculations, how much the ISP's labor gets quantified at. And then they do this big calculation where all the bandwidth that your customers use is automatically calculated by the routers and sent back to the people that manage Giphy. So the bandwidth usage is automatically calculated. Then the ISPs are asked to self-report any value that they put into the system in terms of labor or hardware. So if you buy a screwdriver, you report it. If you spend 8 hours fixing an antenna after lightning strikes it, you report that too. And all the value that they've added zeroes out with all the value that is being taken out in bandwidth by their customers. And so the most exciting part about Giphy to me was this column right here, which shows which ISPs then owe some money back into Giphy. So if you've made more than if you've taken out more than you've put in, then you essentially have to pay money back into the commons to. But if you put in more than you're taking out, then you get a credit that you can carry forward. So it's just such a fascinating sort of open common system that still is accommodating of a lot of other types of economic activity. And I think that's partly why it kind of ended up subsuming a lot of the other, what they now call mesh islands. So like in Barcelona, there's small mesh islands in small parts of the city that are connected through the kind of backbone of larger Giphy infrastructure that's still all managed by this system. Yeah, so that's over time. I was going to talk about one more example. Should I go through this really quick, or? Okay. So the other example that I wanted to look at was here in Sedentapodo, which I'm sure I'm not pronouncing right, and several times I had this conversation. Yeah, I'm trying to find Serantaporo. I'm trying to find Serantaporo, and they're like, Sedentapodo. But that happened over and over. I'm still not pronouncing it right. Anyway, Sedentapodo, I guess, is here. Has anybody heard of this project? Okay, so this is another small farming, a rural, this is called Lasona. This whole area of Greece is called Lasona. It's a rural farming area. They wanted to start their own community network as well. Just to give you some reference, this is Larissa, which is the nearest big town. This is Thessaloniki, and this is Athens here. So yeah, I came to visit these people, and this is the important one of the important parts of the story, because there's a Polytechnic University here which agreed to donate bandwidth to them. They said, we have fiber coming in from the internet exchange, which is here, which is most of the where almost all of Greece's traffic is routed through. We'll share with you some of our bandwidth, but you have to come and get it. And it's about 100 kilometers away over a mountain. So what they did was set up this amazing wireless link. So I'm now sitting here in Sedentapodo looking this way towards Larissa. This is Mount Olympus, and this little crook in the mountain here, this is called Maluna, and Larissa is over this ridge at about another 40 kilometers. So from here on the hillside to here, it's about 40 kilometers, and what they did, since they couldn't get a direct line of sight to the university and the RISA, they set up a 2-part wireless link with a point-to-point antennas here behind me where I'm sitting that goes to the top of this ridge, and then another one that goes from that ridge to the university. It's amazing. And so I decided I had to drive this route and sort of reroute the route through my routing, kind of like, you know, I was playing one of the games that Ingrid was talking about. Like I was trying to reroute, well, anyway, you get the idea. So this is, I drove to this point here. This is now at that point looking back. Sedentapido is somewhere here. And it was just fascinating to spend time at the top of this mountain. And like there was crickets and it was wind and it was beautiful. And I was just thinking about all the different labor that had gone into setting up these antennas. They had leased, similar to Giphy, they had leased part of the antenna from the municipality, from the regional municipality who had gotten a large grant after the crisis. There was a push towards internet connectivity in Greece. They gave out money to municipalities. This particular municipality received a lot of money, put up some antennas here, and never actually really connected anybody. And so then this organization, this group of people in this town, actually a lot of them live in Athens, but they were born in the town and they went away for university, and now they returned back for the summers, but they wanted to connect this village, leased this antenna space for their antennas from the municipality. So on top of this hill, this is one of the cages. There's 3 separate cages for all the cell phone providers, for the commercial radio, and for commercial TV. This is the Sedentapido network that's pointing back to Sedentapido. This is the one that's pointing to Larissa. This is a redundant one that's pointing to another member of the community that lives in Larissa, and this is another redundant one that points somewhere to another neighboring village. This is another one of the cages here that has antennas for, which is out of the frame, for the commercial cell phone provider. And I don't know if you can tell, but they have this adorable little terracotta roof here, which you can see a pile of discards here from when they were setting up these things. Like I guess the guy that was making the tile just like tossed these aside. And so I brought this little piece of tile to share with you all. It says Larissa on it. So if you want to touch this, you can feel that you have been at this critical, should I pass it around? Just be very careful. This is the only thing I've got. If you want to feel like the aura of the space is now brought into this room. And so this is then the antenna pointing the other direction. This is the view towards Larissa. And then this is now in Larissa, here at the university library. Here's the 2 antennas. And then this is the view from those antennas back towards Maluna, to the mountain here. So just to kind of like complete that link. Yeah, I guess the kind of ending on somewhat of a sad note, I guess, this particular, the Sedentapido network hasn't been able to do something similar to Giphy in a sense of like rolling out fiber and expanding the infrastructure. They're still dependent on this wireless link. And I think it's because talking to people about why they haven't tried to replicate that, it's like they haven't, I don't know, they feel that they have a different culture or something. They haven't been able to replicate this kind of trust in this communal activity as much to facilitate this like shared commons. They were talking a lot about the different problems that they've experienced in terms of like why they couldn't get, at one point it was free based on volunteer labor. They decided they want to start charging. People were unwilling to pay the fee, and they would prefer to pay the commercial DSL even though it was slower. So there's all kinds of interesting social dynamics that I'm still trying to figure out in terms of why this particular example wasn't able to roll out fiber in the way that the Spanish example was. So anyway, yeah, that's it.
Hey, use the mic.
Do you have any like notes or like compiled documents about like your analysis of the 2 networks? And is that like public?
I have a ton of notes and I haven't published it yet, but I'm working on processing all that now, and I have a lot more photos too. So I need to. I'm still working through
getting it together.
Piles and piles of. I made a lot of audio interviews with different people, and yeah.
And is the spreadsheet public? The
no,
Giphy one?
spreadsheet. I was hesitant to share that. Like it was very blurry, so I think it's okay to share. But I was a little, yeah.
I mean, like not interested in like the numbers or anything, but like how they go about deciding like where the payments come from.
Yeah. So they have a lot of public documents online where they talk about how they govern their system. There's certain details that like I don't know exactly what specifically they are willing to share in terms of like how their spreadsheets are like laid out and stuff like that. But
It's like what's on their website would be.
Yeah,
like,
yeah, they have like a quite expansive web presence that talks about their rule. They have like a very large document that explains all their governance rules, like in quite like detailed explanations about like, and they have this whole vocabulary of different roles that they've constructed. So it's like, as much as it is like this open peer community network thing, they have like very specific roles. So there's volunteers, there's consultants, so their term for commercial ISP providers. There's there's the governing members, things like that, and then there's just users. So there's all these different classes, and if you go to their governance document, which you can find on their website, they explain quite detailed how everything is calculated. Yeah. It's just, I think it's ep.net.
It's okay. Can I just ask a question really quick?
Hand it back to Zach.
Hey, really interesting that you went to the Battlemesh thing. You know, I think a lot of us have followed it for years, but the website is a little light on documentation, so I think whatever you can tell us is great. And it was actually something very confusing reading the website, but I think you touched on it, and I'm surprised to see is that, is it true that they only had one set of wireless mesh routers and they just reuse them for every protocol?
Yeah.
So they kind of like wipe it every time, or when they go from protocol to protocol, or how does that work?
There was like there was a lot of like nightly flashing, reflashing of I think it's just these those like Ubiquity router. I could be wrong on.
Look kind of like TP-Link. Yeah.
Oh, TP-Link. Sorry.
Yeah.
Sorry. Yeah, I'm a little bit fuzzy on all the details, but it's all in the report. Which I can send a link. They like.
Yeah, sure. But I never saw that. I never got that detail from them before. So that was actually a really fascinating thing to discover from your pictures, is that they only use one set. I thought like everyone brought their own routers, and that was just.
A lot of people brought a lot of routers.
Oh, did they?
Okay. I mean, there was a lot. There's an image I didn't show, but at one point I like was on my phone to like join, and there was like scrolling through Wi-Fi networks.
Yeah.
You know, there was a lot of, and everybody like the LibreMesh guys. They had a couple of their routers there, so that was two other SSIDs.
Yeah.
There was like people from Freifunk brought a bunch. People from the Funk Foyer in Vienna brought a bunch. So there was like just tons of.
Interesting.
But I think that they only had enough to actually, like working, like identical, similarly spec'd hardware to set up one test bed. And then they were flashing it through different protocols and
I see. So to go through be part of the test bed, you had to use the routers in the test bed.
Yeah, yeah.
Okay.
There was like something like, I don't know, whatever. There was like 15 nodes or something like that.
Okay. So did you see if they took any care to say, during the test bed moment when you're actually doing the test, everyone else must turn off their routers, or is it kind of like whatever happens?
You mean just for like the radio traffic?
Yeah. Like a lot of places that'll do this kind of test, they, during the open session, you could just do whatever you want, and then they're like, okay, it's time, everybody, and you turn off, and then you like, have a nice quiet environment.
Yeah,
or is it they just
I mean,
they just leave it?
The nodes that were part of the test bed weren't for general use.
Sure.
But there was still other like 802.11 whatever activity like flowing through the air constantly.
Yeah.
But actually, that was one of the things that was in the report. So if you go to the report, they had like, and this is one of the ongoing debates too. There was a lot of like frustration over the first couple days about how the testbed had functioned in the previous years, and people felt like in previous years they hadn't quite gotten to the point of having the testbed set up early enough to run all the tests. So that was like people were like very determined this time to like actually have the testbed set up very early and to actually be able to run the test. So that I think that was one thing that was a little bit different this time from the previous times, where like in the past they had done some tests, but it was like a little bit less organized.
Yeah.
Here they actually were able to test several different protocols. But they said for future years, that was exactly one of the things that they suggested. Like, we should have some of this happening overnight while everybody's like, there probably be some less traffic.
Yeah, fascinating. It's just hard to tell, and it's good that somebody went so we can, like, it's more than just the website.
Like, the bigger part of it was really like the conference aspect. It was everybody coming together. They were sharing their work. They were giving really fascinating talks about like technical work, about like deploying examples of deploying stuff. It was really just like more of this like community coming, like this international community coming together. So like there was a strong attachment to actually running the test, but I feel like there wasn't much talk about the results of the test. It was more about just like talking about all the work that people have been doing.
Yeah, interesting. Just one last question, because I think we're way out of time. About Guifi, when that I don't know, I forgot the guy's name. I'm sorry, but
Ramon Roca.
Ramon, yeah. When he showed you this manhole where they first ran the connection, how did he kind of present it? Was it that just in Spain it's okay to just go pull fiber if you feel like it? Because in most countries and cities you can't just go do that. So what did they actually do that, or was it kind of like they used that as like, hey, you better get us access?
So, I mean, it was. I think they were pretty confident that it was like dark fiber, like it was not being used. It had been laid, it had been run when they built this road, but it wasn't being used because like they knew that nobody was using it. Like there was no commercial providers that were using it. So it was kind of like this thing where it was their way of proving that it was there and that they could use it. And I think that was like they used it as a leverage point.
I see.
To then be able to establish a more legitimate use.
I see. So
but I will say that I think there's a super strong culture in Catalonia of just like people coming together as communities and taking control of the means of production, whether it's infrastructure, factories, or whatever. So like there was like a very strong sense among the people I talked to. It's like, yeah, we will have our own internet infrastructure. We will take over the main nodes of like whatever. Like so I think there's like a lot less trepidation about like there's a stronger sense that like the people have. So for example, there were some telephone poles that they were running fiber along, and I was like, how did you get the rights to use these telephone poles from Telefonica to run fiber alongside the copper, you know? And they're just and he's like, well, they have like an easement, you know, like the commercial provider has been given like an easement to be able to use private property. These are people's farms to have these posts, and they're like, so we just told them like, you either let us use the poles, or we won't let you put the poles on our property, or we'll build another pole right next to it and just be a huge pain in the ass for everybody, you know? So it's just like a lot more of this kind of just using leverage of the community.
So kind of pressure and very interesting. Cool, thanks.
Next up is Julien Deswaef, and he's a designer, artist, and coder. He's also was a member of a community-owned mesh network in Brussels a while ago, and he's been part of MIC Mesh now for a few years, and he runs the wiki.mesh server.
Down.
No.
It's up again.
From my house, it's not down. I don't know why you can't access.
I don't know why.
It's like,
That's not it's up, but lately it's been down.
what? So, yeah, I've one of the community mesh network I was part of was called Reynolds in Brussels, which taught me a lot about community networks, and that was back in 2000. Yeah, one, I think. And so lately I got interested in Cuba for two reasons. Like 6 months ago with my wife, we decided to go there on a trip. And at the same time I bumped on an article about community networks in Cuba. And so I just came back 2 weeks ago from the trip, and while we were going for vacation and visiting whatever, I wanted to like use that as an angle also to get some more information, some more information about networking there and how it would work. And so this is the result of like prior research, on-site research, and ongoing conversation, which I have with a few Cubans now. So a little bit of history. Cuba in 1959 had a revolution which ended up and turning it into a communist country, run by Fidel Castro here, picture, and now it's his brother, Raul Castro, running the country. But which means because it's a community, it's a communist country, everything is decided at the state level, right? So communications and I mean a lot of like commerce and everything is run by the state, and that's how they decide things to make it simple. So the communication company in Cuba is called ETEXA, or Empresa de Telecomunicaciones de Cuba, and they're the ones who are providing now internet to the country, which is a fairly recent thing. So for two reasons. Apparently, I would say end of the 80s or beginning of the 90s, university researchers in Cuba were interested in participating in the nascent internet, and apparently they were quite active and quite present in the community. But two things happened, or one thing happened, is that in 91 or beginning of the 90s, the Soviet Union collapsed, and Cuba was relying a lot on the help and interaction they had with the Soviet Union. And so the island and the country went into a crisis from there. And then so also for those reasons, like investment in internet and so on, I guess didn't happen. But right now, the Cuban state is progressively getting the country connected in their own way. And this is what this graph is explaining. They're not running internet to telephones, and people cannot really buy internet and connect from their home. Instead, the government is putting Wi-Fi access points in different areas of the country. And right now, this is a graph from 2016. There's close to 400 Wi-Fi access points where people can go in the street and connect to the internet with their equipment. This is for a population of 10 million of people. So imagine 400 public access points and around 600 like internet cafes or somehow. So that's the situation of internet access in Cuba, which basically only 5% of the population can access to. If you live in a rural area, you're not going to have a Wi-Fi access point in your town or your village. There is Havana there, where there's 61 access points, and then the other regions of the country. So that's a graph. This is the service that they're using, or mostly using, the most popular services. I guess most of them I know. I didn't know this one. This is like, so basically what you see is that public parks where people are sitting there with their phones or their laptop connecting to the public internet, I would say. It's mostly provided by the equipment by Chinese company Huawei, which is the largest telecom hardware provider from China. And the financial minister of Cuba has said that they're interested in getting Cuba connected to the internet, but they don't want the bad things from the internet. And so you see the relation here with Chinese internet and how that can play for Cubans, I guess. So basically when you want to connect, you turn on your Wi-Fi, this is what you see. This is in the middle of the city. You only see basically, there's this weird access point, I didn't figure out what it was, but you have an open wireless access and then a closed one. You use the open one. And then basically you see people sitting all day long or next to those access points around Cuba. You spot those access points quite fast because you see a group of people just sitting there looking at their phones, and that's a sign of it. It's especially crowded at night. It's a mess to connect. I mean, during the day it's kind of okay when there's not too many people, but in the evening there's like so many people in these parks that it's basically connection doesn't work. So I tested. I was on vacation. I didn't plan to connect, but just for the sake of testing, I connected to the network. I tried different websites where they're blocking, for example, news from America, like New York Times or CNN or whatever. That wasn't blocked, but other websites were kind of blocked, so it's heavily controlled on what type of information you can access. This is another pictures of people sitting down and looking at their phones. But interestingly, you could connect to the Tor website, and I had Tor on my phone, and I could run Tor, so I could, through that, access, if the connection was okay, certain websites not normally accessible, I would say, to Cubans. So this is a scene that you might see. This is during the day. Yeah, people with laptops in the streets and connecting. Those are the terms and conditions that were here in English that you need to sign to connect to the network. I thought it was interesting that they were like actually not long terms and conditions. I think the point 6 is interesting. It's user will use the provided services in accordance with the ethical and moral principles regulated in the current legislation without prejudice to public security, integrity, economy, and national independence. Basically what it says, you can't, like criticize the government, you can't use it for unlawful things regarding to legislations in Cuba. And that's, yeah, I guess that's why, you can access certain websites and so on. Another thing that is kind of like weird is like, it's mostly used during the day by tourists, and in the evening mostly by Cubans. And so tourists like find shade and internet access. So you need to buy your access. So you go to an official shop of Edexcel, and then you buy a card. And then that card gives you a login and a password. The password, like if you're not careful, you might scratch it off, by the way. And the price is 2 cooks for 1 hour of internet. So 2 cooks is like $2, it's the same thing. You must know that the average salary of a Cuban is $20, $25 a month. So this is 1/10 of their monthly salary. So that's why also like the internet connection is not widespread. I know from a Cuban that has business running inside Cuba and related to internet, that if you want to have internet access for your business or for your home, it costs him $800 a month for a 1.5 megabits ADSL connection. That's the price that they're going through. So that's the sad situation, I would say, of getting access in Cuba. But Cubans are extremely like full of resources, and even if the country has been under like communist and embargo and a lot of like not access to all the resources we have access here for the past 60 years, they're super creative and they're super energetic about like getting their stuff done. And so this is what is really happening, and this is the part I was really also interested in, is there's something called street networks. And basically, they get access to Wi-Fi equipment, and they're building not a mesh network, but they're building a network across the city or across the areas where they live to connect with each other. Those networks are not connected to the internet, but it allows them to connect with each other and play online gaming or LAN gaming, I don't know how to phrase this, or to access to, for example, static copies of Wikipedia and other websites that some people who have access to good connections provide for the others. And that's what I was interested in. I wanted to know what was how those networks were working, who were the people running it, how they were, and yeah, what size they had, how they were managed, what type of protocol they were using, how they were distributing IPs, and so on. And I had a lot of contacts. I had a lot of people, phone numbers, thanks to contacts here that I had in New York, but I could, so far, never managed to get real proper answer. But so I was there, and I started like looking for it. There is this article that was published about 3 weeks ago in Wired that explains a lot of these things. And they had this map in the Wired magazine where they say that basically you have Havana, and this is the extent of the street network that is around Havana. So it goes all across the island. You saw that on the map. But basically, I visited other cities in Havana, and I could see that in all of them that I visited, there was street networks. Because what I could see is that here is, for example, there is a Ethernet cable running from the rooftop of a house to another one. And that, I mean, as my eyes were getting trained to see that in the cities, I could see those cables running from one rooftop to another, and it's barely attached. And that's how the network is built, mostly. Or they're having this on the rooftops, which is basically a wooden pole with basically two ubiquities protected from the rain or whatever. I'm guessing this is basically put like this because I know from Louis, who's a member of NYC Mesh, or he was at least here a few times, that some people smuggle ubiquities in their luggage when they go to Cuba, and to easily smuggle it, they dismount them, right? And they remove the casing, they just bring the electronics. So maybe that's a way to basically protect the electronics again from and this is basically when I was staying in Airbnbs and whatever. I would usually like go to the rooftop where I was and I would look around, and this is what I could see, for example. Like really, this was in Trinidad. There were forests of ubiquities. Being there. The funny thing is that there might be two uses for it. One use could be that they're just trying to get the connection that that lives, for example, the official connection provided by the government that is in a public park 2 blocks away. So they use a ubiquity just to be able to navigate to access internet from home. Or they do it also, I guess, to do the street networks, because some of the access points are using video game names. So I'm guessing that's kind of like the reason why they you know, the excuse to build a network, right? It's just about video games. So that's another picture of like, and it's funny because it took me a couple days to see those things. You know, I mean, it's also a different country. I've never been there, so there's a lot of stuff visually that gets to you. But then once I started seeing the antennas, I could see them everywhere, especially in richer areas of the cities, of course. There's a website, you can browse it from here, of course. It's called Revolico, which is the equivalent of Craigslist, but for Cubans. They have a static copy of Revolico that is every day being clones on their street nets, and that's how, if you check this is a screenshot of the part that sells modem and Wi-Fi equipment, you'll see that there's like countless of, how do you call that? Propositions, you know, to like buy or exchange Wi-Fi equipment. You must know that this is one of the great things about Cuba. It's the contradictions, right? This is a communist state country, so everything is regulated. Like, you're not supposed to start a shop, or you're not supposed to like sell things out of the control of the state. But this exists like in a parallel world kind of thing, where ubiquities are sold at 200 cooks, for example, $200 for a ubiquity, while we can access here the same equipment for $50. And the funny thing about Ubiquiti is an American company. So this is clearly stated on their website, is that no Ubiquiti products can be transferred without license to any country, and in one of those countries is Cuba. So that for me is one of still like the questions that I have back from this trip, is that I've never seen so many Ubiquities per square meter, right? And they're not supposed to get them for two reasons. One is the United States not allowing the company to sell them over there, and second is the state is highly regulating what type of telecommunication equipment can enter the country. So this is, I mean, for me, still an act of research, and yeah, that's for me is like the best image of, I mean, or one of the image of Cuba is that I think they're into open source, they're into creative use of tech. They're incredibly like smart at doing a lot with a little that they can have access to. And one of my goals of going there was to try to connect with Cubans that are involved in this field and to make a bridge with what NYC Mesh or other mesh networks across the world would do. And it's happening slowly. It's hard to get them to talk. We planned with Brian that there's 2 Cubans here in New York that are really involved in these things, and I wanted to get them here, or at least one, to get them here to talk with me, or at least be presenting it. But they're not too comfortable with that for multiple reasons. But yeah, I'm still researching this. I'm still interviewing them and trying to get as much information as possible from them. And so if you have any contacts or if you want to share any information, please contact me, or want more info about this. I can point you to the articles I was referencing. At the same time, also, I want to talk about something. There's something called CubaConf, which is an open source conference happening in Havana in November, I think. And I would definitely encourage you, if you have the chances, to go there. There's 2 things that I don't want happening somehow, is that I don't want them to get Chinese internet, but I don't want them to get American internet either. I think they're smart enough to get their own internet and to build it from scratch, as they've proven they're doing it. I want to support that. So that's it. Thank you. Do you have any questions?
Any questions? So those forests of routers, what are they? They're not talking to each other, or are they?
I think some are and some are not. It was hard to get the information there because either the people I was talking to were denying that this was happening, or they didn't have the knowledge and it was the neighbor who had the knowledge. And the neighbor was not there. So it's somewhere like in Havana, for example, the reaction was more like, oh no, it's not us. We don't know what's happening. It's the neighbor.
Because it's illegal. Or
Yeah, it's not. I mean, yeah, it's illegal. The legality of it is complicated, and they're maintaining it, or it is still tolerated because they're very careful what they're doing with those networks. So they're not going to start opening forums to criticize the political system or whatever. They're self-regulating because they want to keep it, and they know that if they start fooling around with it, they might be shut down quite quickly, which apparently has happened a few times. So some, I think, try to just repeat the public access, while some other are really connecting. Maybe some are doing both. It's hard to know.
There's also a lot of piracy. They have a lot of American movies and stuff are passed around Cuba.
Yeah, that's something
they tolerate a lot of that.
I haven't talked about that. That's a whole field of, is that but that was less about like mesh networking or networking from an infrastructure point of view, but they have what they call El Paquete, which is basically every Monday there's 1 terabyte of data from the internet that is being shared among USB keys and through a network of copying stations. And so yeah, it was true. Like Monday night, I could hear in the Airbnb where I was, I could hear Hollywood movies being played, like like Universal or whatever, and they get access apparently to like all the latest series that we're watching, Game of Thrones or whatever, and all that is going through a network of. So yeah, they're not disconnected, but it's really interesting what's happening. Thanks. I hope I wasn't too long.
Thank you.
Thank you.
So up next we have Oliver, who's been helping us with the mesh for a lot longer than I have, I think. He's going to talk about Filecoin, which is an altcoin like Bitcoin.
Yeah, I have nothing to do with Filecoin, but I just think it's really cool. I want to share it with you.
Like that.
Yeah, sure. I'm gonna make this like pretty fast and then just take a lot of questions because I'm not really sure what you guys want me to talk about. But do any of you guys know about Filecoin? Do you know about IPFS? Okay, so it's the same team behind IPFS is working on Filecoin, and basically the goal is to do what Bitcoin did for money to like storage, like Dropbox or Amazon Web Services. So basically, there's a whole bunch of components to this system, but it's a way that people could share their hard drive space and get paid for that. It's an exchange, so people could make bids and take offers. So it's like a whole marketplace. And the whole goal of this is to create like a really low cost, like decentralized and just more robust alternative to like Amazon or the places where like data is currently being stored. So I've been reading this white paper, which is like a huge document. They're talking about exactly how it works and stuff. So I'm still wrapping my head around it, but basically, I'm not going to get too deep into this, but basically like the big breakthroughs that they've made are proof of space and proof of space-time. So what that means is like proving that you're actually storing a unique copy of some data and proving that you're doing that over a period of time. So this is like the really important breakthrough that makes this whole thing possible. I could talk more about how that works, or I'll come back to that later if you guys want. Also, the reason I'm talking about this is because I think it's really relevant to what we're doing here, and like other people were touching on this before. Like, how do you incentivize something like this to get built? Like, you can't really rely on volunteer labor. And also, like, Julien has been hosting wiki.mesh, which is awesome, but it's like one person hosting a site, and it goes down, and that's totally like antithetical to the whole idea of a mesh, which is resilient and distributed. So Filecoin just like is really relevant in those ways. Specifically like incentivizing a whole network. Does that make sense? Like, is there anything you guys want me to talk more about? Any questions?
Does it have an actual coin like Bitcoin?
Yeah, but it's not based on Bitcoin. It's like a whole new. So that's like the coin is the way miners get rewarded. You earn Filecoin by hosting people's files, and then you can sell that for money or, use it to buy storage space.
Proof of stake.
So that's what I was talking before, like the proof of space and the proof of space-time. Basically, like the reason this is, or some of the challenges when making a system like this are, like what's called a Sybil attack, which is where a lot of people or one person claims to be a ton of people hosting like this data, but they're really just storing it on one copy, but they get to reap the rewards of like 1,000 copies of it. So the proof of space ensures that each time you're saying you're hosting a copy, it truly is like a unique copy taking up that amount of data on like a physical disk somewhere. And then proof of space-time prevents people from like saying that they're hosting it when in reality they're like creating the data from some algorithm or like just fetching it from another server. Like this really ensures that people have the data and they have as much of it as they say they have.
I get into conversations about Bitcoin and mesh routers all the time and blockchain, and I can never figure out how the router could possibly run a proof of work or whatever.
The the idea with how a router could run a proof?
Yeah, the idea is to incentivize people to put a router on their roof by having some altcoin reward for that.
Yeah, that's a really good question, and I have no idea how you could apply this to incentivizing network bandwidth or availability. But if someone could figure that out, that would be really useful, I think. And I know there's a few people working on that, like Source Wi-Fi and Althea Mesh are two projects I know of.
Kind of interesting. I mean, it's definitely interesting, but given that I could just read the white paper, but given that you have already read part of it, what do you think about these two things? Firstly, that since they're proving that you have space, they probably put unique data on every section and they checksum it, and if you put something there, it's checksummed, and then you prove that you have totally unique space. But by doing so, kind of as you said, for each replica, you probably have a different copy, and it's encrypted differently or set differently so that it's checksummed differently to prove that you have another copy. Yet, you probably want replication. So it seems extremely wasteful in terms of global storage, because now we have to have, for things which could be deduplicated and could be copied multiple times, and you could mirror it like explicitly, you now must generate another copy, right? And so like if you were to say put a repo or something, repository of data, you have to do so much extra work to store things, right? What do you think about the way they're doing that?
Trade-off, like it's not the most maximally efficient use of storage space, but I think the value of having a network like this is definitely, I don't know exactly like how much of a trade-off it is, but I think it's probably worth it.
Okay,
just
interesting.
To make it possible.
Okay, that and shoot, what else was I thinking? Oh well, I forgot.
As a video guy, I can kind of see that having people on a local network who I have masses of data, which is, irreplaceable, that I need to back up on a constant basis. So I can see it kind of being a useful thing, in that aspect to have something like that. But there's two things that I've shot recently that I think about when it relates to this, and one is fog computing. Are you familiar with that? Fog. F-O-G.
Oh, fog. Okay.
So if you look it up, this is a whole movement in computing, which it's like cloud computing, except, like the difference between fog and a cloud is, fog is when the cloud moves to the ground and spreads to the outside, and that's exactly what fog computing is about. Instead of you sending your processing up into the cloud, the processing is coming down into the edges. And they're thinking about this very much in things like with cars and stuff like this, where they can't wait for someone else to do the computing to know if you're going to crash into something. So you need ubiquitous processing, so that Filecoin could be CPU coin. So there's that aspect of it. Another thing that I was at the IGF USA, and they had a thing on smart networks, and the guy from Comcast talked about intelligent content distribution. He said that Comcast have come up with this thing that to give every second of content an IPv6 number. There are so many IPv6 numbers that they can take a whole movie and give every little piece of this its own IPv6 address, and then use routing to find it on the network. And I'm still getting my brain around this, but it's it's an interesting thing to think about, that IPv6 is actually a system that you could use to identify content and bring into your network.
Yeah, just to go touch on your point about fog computing, I think a big motivation of this is just a general trend that the amount of storage space we have in the whole world is increasing dramatically faster than the network capacity. So this is pushing more content out to the edges of the network. Is that one way of dealing with that big change?
So my question is about
so this would encourage people to share drive space, and then so use unused drive space, share it among people, and then have store content. So here, since it's kind of like becoming a coin which can then be exchanged for other types of monetary things, that's how you encourage people, right? There's a reward.
Right.
Okay, but as I understand, there's still the question with Bitcoins, whether the amount of electricity, energy, and hardware and power that you put into mining to gain Bitcoins is still more expensive than the value of the Bitcoin itself. So in this case, isn't that also somehow a case where you know, like what are the economics of this, and is it worth it to just like, because I'm thinking, oh, but then maybe somebody can like start buying free space somewhere and then use that to generate money that they then change in the market, and then play with the values of the market to generate.
Well, just first of all, I think it's fundamentally different from Bitcoin in the sense that Bitcoin relies on proof of work. So people are doing a lot of work, like using a lot of energy cycles. This is different. All the work is done up front to generate like the ability to say that I have this data. But after that, you're not doing a ton of work. You're just like responding to verification requests. But you're not constantly doing work over and over again. So in terms of energy efficiency, it should be better. Going back to what Zach said about like space efficiency, I'm not sure exactly, but there's a ton of unused capacity out there, and I think it could have like a really interesting economic effect of lowering the price of storage and just utilizing unused space, which I think would be a good thing.
And a side question, is it related to StoreJ?
It's a related project, but it's totally different people
Okay.
working on it.
But it's the same technology behind it, or no?
No, it's based on IPFS.
Okay.
So if you're interested in this, definitely check out IPFS.
Does the paper specifically reference IPFS as a requirement for the implementation, or?
Not specifically. It's all based on Merkle trees, so it just uses a lot of the same concepts. I don't know if it's specifically tied to IPFS.
Okay.
But it's fairly like basic primitive data structures. It's not like a super specialized system.
Yeah, I remember it's kind of, I was kind of thinking something similar to what Julien said, which is, you know, every year storage goes down in price, and, you know, I'll say something untrue, but it's like half every year. It's not, but let's say it is. So you're kind of basing something on a coin, like a coin is being based on a thing which is halving in value every year, but you want your coin to get more valuable generally because people want to get it. So yeah, I know it's not true, but you know, that's but it's going down at a rate, right? A constant rate, and with Flash maybe exponentially. But you know, it's kind of, isn't it? It's a weird thing that's like self-defeating almost, right? Like your storage is getting cheaper, so in a year from now, the coin's be worth half as much because you can store twice as much for the same price.
Isn't that assuming the demand for storage is staying the same?
Demand is higher, yeah. That's a good point. Yeah, I see what you're saying. Supply, demand versus, yeah, good point as well. Well, supposedly you can't compress because they would give you unique data, right? So.
Just think about media for a second. Now you're 4K. Think about just media. We used to have really low resolution or standard resolution for a long time. Now you have 4K.
Higher use of that.
Right. So I think it'll be good to see how the other graph looks like next to this.
Yeah.
How is storage demand going up over time?
I mean, I'm just like, I just like took like a really quick like look through the white paper, like what's up there, and it talks about like proof of storage and proof of replication, but like a lot of the storage that's out in there in the world right now is dedicated toward like replication and backing up. Because there's so much data that a lot of storage is just based off decentralization is just basically replicating data over and over again and trying to prove which data is correct. In the Filecoin scenario, whose onus is it to prove that like the data that's replicated is correct? Like how does it, like when we replicate data, like who defines whether or not which piece of data is actually the correct piece of data and what's corrupted or not?
So, do you know about Merkle trees?
Not.
So this is like the fundamental, like, way that this all works. Merkle trees are like, do you guys know what hashes are? Hashes are like a way of taking any amount of data and then transforming that into like a unique, like, string basically, a unique identifier. So Merkle trees are like a tree of hashes in which each hash is like pointing to the previous one. I don't know if that makes sense, but like, so these arrows represent like some sort of reference. So hash 1 is referencing hash 1, which is referencing the top hash. So just by checking that top hash, you could verify the integrity of everything below it. So you basically, if you wanted to store some data, it would just be one hash, like 64 characters or something. And using that one hash, you could actually verify the integrity of everything, any amount of data. Does that answer your question? So I know it's like kind of a big question to answer. But yeah, if you want to look into it, this is like, and then also that's the way IPFS works.
And blockchain too.
And blockchain, yeah. Git, BitTorrent, everything's based on Merkle trees.
Thank you. We have one more to go.
No, I think that's it. Jesse decided he's not ready for his presentation, so.
Yeah, so I'm about halfway there. So I just don't have enough material to really make something that's colorful enough to make a good presentation.
Do you want to just take a bash at it?
Sorry?
You want to just take a bash at it?
Sure.
Preview maybe?
Yeah, so I think like Ingrid was saying earlier, like even software developers like us, can get, I mean, the internet is confusing. It's hard to understand how it works. And I've been helping out with the mesh for a couple months now, and definitely wanted to, or realized like how little I understood about how networking actually works, routers and switches and how the pieces come together, how you would actually build a network, and wanted to build a model. I was also helping try to build some of the firmware. So we have a software stack that runs on all the routers, which we're hoping to update, and in an effort to build some of that, got frustrated in not being able to build it, and wanted to look at some alternatives for the software. And it's really complex. There are a lot of pieces that make that software stack work. And I think I found it at least really difficult for myself to understand or to evaluate different pieces of software we might use going forwards, whether that was the next version of the software we already have or another one. Just too hard by just reading the documentation. So I wanted to build or be able to at least experiment with like a synthetic network. What would be an easy way to kind of see this stuff in action? Whether, like I said, that was our existing distribution or another, be able to spin up, at least we have probably something over 30 nodes running in the mesh right now, at least that many, but maybe more, and see how it worked, like how much traffic was going in between which nodes, what would happen if you segmented the network in a different way, and I looked at a couple pieces of software that already exist. There's a product by Cisco, which didn't, at least as far as I could tell, I didn't actually try it. It's called VIRL, I believe. Didn't have a GUI, really. It was kind of difficult to set up. There's another one called GNS3, which I played around with a little. But the GUI for that is like a native thing. It's pretty good. It's based around spinning up the instances, the nodes, as full-blown virtual machines. I think there is now a way to do it with Docker, so you can do it with containers. But I wanted something that was much simpler. Like I knew how to use kind of like raw Linux containers, just with namespace tools and with systemd nspawn, like a very lightweight tool to bring up containers, and wanted to have something that was at its core a server that would basically just be able to spin up Linux containers on a single machine, and then to expose the interface for controlling it and adding what are called virtual Ethernet devices in between the nodes with either programmatically, or sorry, not programmatically, through a command line interface or with a graphical user interface. So really my hope was to build something that we could use, and just to step back a little bit earlier on, Brian has a database, like a full database of everybody who has an active node or like a potential node in a spreadsheet. And we were able to get that data out as GIS data so that we can look at each of the nodes and where they are, how far apart they are, and which nodes connect to which nodes. So there's a list of all the nodes and then their links. So potentially being able to take, I wanted to have a tool that would be able to take that data and basically inflate a synthetic model of our existing network with, and to try it with different pieces of software running on the nodes firmware. So far, I really just have the server part, the component which, and I would say, you know, you can interface with it from the command line, but you have to kind of bring your own images, whether those are binaries, x86 binaries that are built by LibreMesh or QMP or whatever you have, or you can build your own. It will allow you to basically create nodes, assign them to a given network, so you can kind of have multiple networks running at the same time, and then to easily, and you can do this already, even at the command line with IPRoute, if you guys are familiar with that, Linux command line tool for working with the kernel networking stack, but to be able to bring up these virtual Ethernet devices and insert them into containers to kind of simulate these links that we have in real time. So that piece of it basically works, but I haven't actually put together or taken the data from the spreadsheet and put together a model to actually look at. So it's not very exciting, and hopefully, if I can get a little further along with it, we can put together, you know, a graphical front end for it, and then hopefully be able to generate some kind of statistics, a graph. I'm not sure. I mean, it'd be interesting to know what they did at Battlemesh in terms of, you know, how do you consume the output of these tests? What are you supposed to look at? I don't really have an answer for that yet, but hopefully, you know, if we can have a virtual Battlemesh, if you will, you know, the ability to kind of bring up all these routers and interconnect them synthetically, maybe that will be faster and leave us with more time to look at some of the best ways to visualize this information so that we can make sense of the firmware options that are out there, or software options that are out there, so that we can, you know, move forward with our existing stack in the most painless and efficient way possible. So yeah, doesn't really exist yet, but I'll post the link to the Slack channel software to the GitHub repository. You can check it out. I think ideally we would be able to put that up and run it on a web server somewhere so that anyone could kind of just play around with it without actually having to deploy it. But yeah, feel free to take a look. Oh.
just mention we have regular firmware meetups, so where we discuss this and try and build firmware.
Yeah, it's a bit frustrating, but we're making slow progress.
Yeah, there's one tomorrow night.
Oh, awesome. Yeah, I have one of the Lego waves, which I can bring that.
Thank you.
Yeah. Any questions?
So it's 8:30. We've actually got the room till 9 o'clock if people want to hang around and chat or ask each other questions. So.
Well, do you want to recommend a bar, Brian?
And you had an announcement?
Yeah, I was trying to make that, I would say shameless plug, but I'm definitely ashamed at plugging this. But anyway, I just want to say that August 25th and 26th, I'm participating in an event that I thought people here might be interested in. It's up in the Catskills at this, there's a radio station called Wave Farm. It's WGXC 90.7. It's like an experimental radio station, and they're hosting a 2-day event called Lodge. That's like a sound art music festival, and based off of my interest in mesh network, we're going to be kind of simulating a mesh network with CB radios. So we're going to have like a chain of CB radios that are going to be relaying information. So if you want to come and participate in a weird kind of like mesh voice over CB fun game thing and listen to some cool music, it's August 25th and 26th. I can post the link somewhere or something if anybody's.
Yeah, where's the info on that?
You can, if you go to like Wave Farm, just Google Wave Farm, their website, and click on events. The event is called Lodge, Lodge, and yeah, there's like some really cool bands that are going to be there, and I don't know, there's food and stuff like that.
I'll post the link on the meetup for tonight.
And I can post the Battlemesh final report link to you, just in case that's easier.
Do you remember what is it on the GitHub/Battlemesh?
Yeah, it's, I have it here. I'm going to put it on the screen or something, or?
Yeah, do you know the URL?
It's a long.
Post it to Slack, I guess.
Okay, yeah, it's like a long GitHub thing, you know, but it's on their GitHub page.
Did they do graphs or?
Yeah, a lot. Yeah, there's a lot of visualizing the results, for sure.
Okay, is that it, Brian?
Yep.
Okay.
No, we're not supposed to say anything. No, we're not supposed to say anything. No, we're not supposed to say anything. No, we're not supposed to say anything.